Hello students, hope you are doing well. In this lecture, we are going to discuss characterizing the existing network and sites of Unit 1 applying methodology to network design for the subject Enterprise Network Design of B7 semester IT University of Mumbai. This lecture covers customer input, sample site contact information, sample high level network design, auditing or assessing the existing network, tools for assessing the network, analyzing network traffic and application, tools for analyzing traffic, network health checklist, summary report, creating a draft design document, time estimates for performing network characterization. So these are the main topic of this lecture for characterizing the existing network and site. Characterizing the existing network and site. The second step of design methodology is characterizing the existing network and site. The first step was already discussed, identifying customers' requirement for organizational and technical, organizational goal and constraints, technical goal and constraint. Information collected and documented in this step is important because the design might depends on the existing network's hardware, software, and link capacity. In many cases, a network already exists and new design relies on restructuring and upgrading the existing network and site. Even when a network does not exist, the site will be network still should be examined. The lecture present insight into process of examining an existing network and sites and describe the tools used to gather the data, assess the network and analyze the network. The checklist to assess the network health is also discussed in subsequent sections. Guidelines for creating summary report are introduced. The discussion concludes with the draft design document and estimates of time required to complete the entire characterization process. So, in first step to do this performance of second step is customer input. Customer input, review existing documentation about the network and use verbal input from the customer to obtain first impression about the network. Although this step is mandatory, but it is not sufficient and some results might be incorrect. Second step is network audit. Perform a network audit, also known as also called assessment, which reveals detail of the network and arguments the customer's description. And third step is traffic analysis. If possible, use traffic analysis to provide information about application and protocols used and to reveal any shortcomings in the network. Although traffic analysis is good idea in principle, it is often too costly in terms of time and effort to do in practice. Now come to consumer input. This is the first step. So we discuss consumer input as a whole. Customer input includes all pertinent network and site documentation. This information is very important. So these information include site contact information if you are planning to deploy your network in remote, existing network infrastructure. So from physical documentation and diagrams and site surveys as needed. In this survey or in this diagram, we can find location and type of servers, including a list of network applications supported, location and type of network devices, cabling that is currently in place, including network interface connection, table, and worksheets, writing closest location, environmental control, including heating, ventilation, and air conditioning requirement and filtration, location of telephone services, demarcation places, WAN speed, and location of WAN connection feeds, location of power receptacles, and availability of additional receptacles, and power sources. So, as existing network infrastructure from logical topology diagram, including addressing scheme and routing protocol in use, and the infrastructure services supported such as voice, storage, and wireless services, information about expected network functionality. So the documentation should also allow the designer to determine information about the plant and existing network and site, including network topology. So first thing is network topology. It includes devices, physical and logical links, external connections, bandwidth of the connection, frame type, data link and encapsulations, IP addressing, routing, protocol, and so many information associated with network topology. Now come to network services. What are the different services like security, quality of services, high availability, voice, storage, wireless and video, and so many other information associated with network services. These all are interconnected. And then finally come to network application. Example includes unified messaging and voice delivery. So all this information should be included in the design document. It is also forms the basis for breaking the network into modules. This is example of sample site contact form. In this sample site contact form, site and location name, site address, site contact, it is needed if remote deployment is planned, like name, title, telephone number, fax number, cell phone number, pager, email address, out of hours contact number. Is the site owned and maintained by the customer? Is this staff site? What are the hours of operation, site address, what are the building and room access procedures, are there any special security safety procedures, if yes then what are they, are there any union labor requirement or procedures, if yes then what are they, what are the locations of equipment cabinets and racks. So these are the information included in sample site contact form. This is sample high-level network diagram. In this diagram, server farm, management workstation, switches, routers, internet, PSTN, IDN, ISDN, WAN, different networks in heterogeneous networks are connected. So using this diagram, we need to answer some question. With only this diagram, many questions remain about the network and expected network functionality. Some of them include what is the IP addressing scheme, whether it is IP version 6 or IP version 4, what level of redundancy or high availability currently exists in the network. Redundancy is very important. If redundancy is available, then the servers are also available. If one fails, then another automatically takes place. What are details of security design? What type of links are in the network? What are the link speeds? What are the plan layer 2 and layer 3 topologies? How is connectivity provided to remote site? What network infrastructure services are in use, such as voice, video, and what is plan? Are existing wireless devices in place, or are any wireless deployment is planned? What routing protocol are in use, and are there any server farm or remote data center connectivity requirement? Like this is the example of server farm. And last question, what network management tools are in place? It will be discussed in detail in next slide. Auditing or assessing existing network. This is coming under network audit or assessment. It is second step in acquiring information about existing network. The auditing process starts by consolidating existing information, and customer provide up-to-date information can be gathered from the existing management software used by the customer. If the customer has insufficient tools, the designer can choose to temporarily introduce additional software tools if they prove useful. Those tools can be used in the network permanently during the operation and optimize phases. An audit provides details such as a list of network devices, hardware specification and version, and software versions of the network devices, configuration of network devices, output of various auditing tools to verify, augment the existing documentation, link CPU and memory utilization of network devices, a list of unused port, module, and slots in the network devices to be used to understand whether the network is expandable or not. The auditing process might require minor or temporary network changes. Automated auditing should be used in large networks for which a manual approach would take too much time. However, the auditing process balances both detail and effort to produce as much information as needed as possible. For example, it should be required that large set of CPU heavy auditing tools by purchased and installed in the customer network to collect configuration of network devices. The auditing process is typically performed from a central location such as a location in a secure environment that has access to all the network devices. So in this diagram, we have shown what is the process. Network audit information source. First thing is existing documentation is used, and then network designer check using existing tools and management workstation existing management software. Using these all things and existing documentation, it will be compared and it will design for new tools. So this is coming under network audit information source. This figure shows sample information that a manual or automated auditing process collects from the network management workstation. The auditing process should collect all information relevant to redesign. The same process should be used for all network devices affected by the design. So, what are the things for network workstation? Use auditing tools to collect network information, and then here in router, what is the type of router? CPU type, average CPU utilization, memory size utilization, flash size, iOS version, configuration, and routing table. And for this link, interface type, speed, average link utilization, identify unused interface, and modules or slots. So using all these things, we can collect the information during network audit. Let us now discuss different tools for assessing the network. A small network can be assessed without special tools. Monitoring commands can be used to collect relevant information on a small number of network devices. The approach can be semi-automated by introducing scripting tools to execute monitoring commands automatically. But in case of large network, a manual auditing approach is very means it is too time consuming and less reliable and less effective. So there are some tools to monitor or assess the network. Cisco works to map a network and collect various type of information such as network topology, hardware and software version, configuration, etc. So this is Cisco work. Cisco work is very important. Next is third-party tools such as WhatsApp Professional. It is not WhatsApp. WhatsApp Professional. You can download it from here. From IPS which SNMPs from Castle Rock Computing. Open source Cacti, which is a successor to the popular multi-router traffic grapher Cacti. NetMRI from NetCordia. This is NetMRI. from NetCordia and NetVoyant from NetQoS. Other version tools to collect relevant information from equipment manufactured by those vendors. Other tools can help characterize and characterize the existing environment. For example, instead of a full wireless site survey, it can be helpful to conduct a brief RF sample of environment using enterprise level tools. Such tools include air magnet survey. This is air magnet survey. Spectrum expert, AeroP, Cisco Airport Site Survey Utility. Air Magnet Survey Pro to perform an RF site survey. Cognio Spectrum Expert, a spectrum analysis tool, and laptop applications such as AeroPeak from Wild Packets, network analyzer software that support decoding of wireless data packets, and Cisco AeroNet Site Survey Utility. Wireless networks are described very detailed in different manuals like wireless network design consideration. So these are the different tools available and websites are also available. Manual information collection example. The auditing process can be performed manually or relatively small network using various monitoring commands. So this figure shows three different types of network devices, information to be collected and command that can be used to obtain the information. So first device is router. Here you can see the router, and second is switches, and third one is Cisco Secure PIX security. So in case of Cisco routers that run Cisco iOS software, the show tech support command usually display all information about router. Show process CPU can be used to determine CPU use, and show process memory can be used to determine memory uses. So here you can see show tech support, show version, and show version of different commands. On Cisco switches that run Cisco Catalyst operating system CatOS software, the most useful command vary depending on the version of software. Useful commands might include show version, show routing configuration, and show technical support. So these are the different commands associated with switches, and this is router, and this is P PIX security. Okay. And on Cisco Secure PIX security appliances, the show version and write terminal commands are useful. So let us see each one by one. Here we see the command in router, Cisco router. So this command name is show process CPU, and this is coming under manual information collection. So when running this command, we get these information: CPU utilization for last 5 seconds, 1 minute, and 5 minutes. The first number in the ratio indicates the total CPU utilization. The second number in the ratio indicates percentage of CPU time that was spent at the interrupt level, and 1 minute total CPU utilization for last minute. So in this particular process load meter, this is 0%, 0%, and 0% CPU utilization for 5 second, 1 minute, and last 5 minutes. Next is PID, that is process ID. So here it is a unique number for a particular process. So this is process ID. Then runtime in millisecond. This is total CPU time expressed in millisecond that the process has used. So here in for process 1, it shows 2464 millisecond. Next is invoked. Invoked. How many times this particular process is invoked or called by a system. Next is microseconds. Microsecond of CPU time for each process invocation. So here it shows 5 microsecond. Then 5 second, 1 minute, and 5 minute already discussed here. TTY is the terminal that controls the process. So in which terminal we are running this process. So terminal 0 is main server. Terminal 66 is virtual execution and process. The name of process like load meter, virtual execution, IPsec, mock, top pan, check heaps, chunk manager, pool manager, timer, serial background, alarm trigger, environment, ARP input, DDR timers, dialer event, entity MIB API, and logger. So this is the manual information collection example. This is another example of manual information collection. It shows show process memory. This is the command name. So while running this command in router, it gives total amount of held memory. So here is total. This is total amount of held memory. Use gives the total amount of used memory. Free is the total amount of free memory. PID again it is a process ID. TTY is the terminal that controls the process. So this shows the TTY. Allocated byte of memory allocated by the process for a particular process number 0, 0, 0, 1, 2, 3, 4, 5, 6 and so on. Freed bytes of memory freed by the process regardless of who originally allocated holding the amount of memory currently allocated to that particular process. Get buffs. So number of times the process has requested a packet buffer. RET BUFS red buffs. Number of times process has relinquished a packet buffer. Process. So this is the process. Init means system initialization. SCHED scheduled, the scheduler, and dead is the process that are now dead as a group. Total, it is not shown in this figure, the total amount of memory held by all process. Some automatic information collection tools are available like Cacti. This screenshot is from open source Cacti application showing a list of devices found in the network. These are the devices, what is the status, host name, current millisecond, average millisecond, and availability. And you can find all the devices using this. So this is automatic, means no command line is required to operate on this. This figure shows a screenshot from NetMRI. Analyzing network traffic in application. Traffic analysis is the third step in the characterizing a network. Traffic analysis verifies the set of application and protocols used in the network and determines the application's traffic pattern. Might reveal any additional application or protocol running on the network. Each discovered application and protocol should be described as importance to the customer, quality of service related requirement, security related requirement, scope, or in other words, we can say that the network module in which the application or protocol is to use. So, how to do this network traffic analysis? So, first step is use customer input to list expanded application. Second step is use traffic analyzers to verify the customer's list of application. Step 3, present the customer with the new list of application and discuss discrepancies. And step 4 is generate the final list of application and their requirements with respect to importance, quality of services, and security as defined by the customer. For example, uh, we can say name application number 8. Okay, name is the application number 8. Second thing is description. Description, suppose we want to use account software, so account software. And third thing is protocol, which protocol we want to use, so maybe TCP or UDP, depends, and with port number 5151. Next is number of servers, 2. Why 2? To maintain the redundancy. Number of clients, 50. Scope, it is campus wide, and importance is high, and average rate is 50 Mbps. Okay, this is capital M, Mbps, with 10-second burst. So this is how uh, this network traffic is analyzed. Assume that a customer requirement concern quality of services on WAN connection with limited bandwidth. In this case, the information collected is relevant because it describes number one, the application TCP port 5151, which is required for performing classification. Second thing is the importance of application. This information is useful for evaluating how much bandwidth should be allocated to the application. And number three, the correct the current bandwidth consumption according to the present quality of service information. However, that this information might not be relevant should be customer requirement instead concern a secure and resilient internet connection. In this case, it might be necessary to gather additional information. Tools for analyzing traffic. Tool used for traffic analysis ranges from manual identification of application using Cisco iOS software commands to those in which dedicated software or hardware-based analyzers capture live packets or use the Simple Network Management Protocol (SNMP) to gather interface information. Analysis tools including Cisco iOS network-based application recognition (NBAR). NBAR can be used to identify the presence of well-known application and protocols in the network. Second is Cisco iOS NetFlow technology. NetFlow is an integral part of Cisco iOS software that collects the measures data as it enters a specific routers or switch interface. NetFlow allows the identification of lesser known application because it gathers information about every flow. This information can be collected manually using Cisco iOS software show IP cache flow command. Which command we use? Show IP cache flow. CACHEFLOW cache flow command. Alternatively, Cisco Network Service CNS NetFlow Collection Engine NFC allows automatic information gathering of each flow in the network agent. Then come to third-party hardware or software-based products. Can be used to analyze traffic in different subnets of the network. These are open source Cacti, already discussed, network general sniffer, a wild packet, ether peak or aero peak, solar winds, Orion, and Wireshark. So these are the remote monitoring probes can also be used to support traffic analysis. So NBAR is tool for analyzing traffic. What is NBAR? Cisco iOS NBAR is classification engine that recognize a wide variety of application including web-based and other difficult to classify protocol which utilize dynamic TCP and user datagram protocol port assignment. Other quality of services tools within the network can be configured to invoke services for the specific application that is recognized and classified by NBAR, ensuring that network resources are used efficiently. QoS. The purpose of quality of service is to provide appropriate network resource such as bandwidth, delay, jitter, and packet loss. So these are the two applications. Quality of services maximize the return on network infrastructure investment by ensuring that mission critical application receives the required performance and that non-critical application do not hamper the performance of critical application. Quality of services is deployed by defining application classes or categories. These classes are defined using various classification techniques such as NBAR that are available in Cisco IOS software. After these classes are defined and configured, the desired quality of services features such as marking, congestion management. So, quality of services features. First thing is quality of services features such as marking, then congestion control or management, congestion avoidance, link efficiency mechanism, link efficiency mechanism, and or policing and shaping. So these are the features associated with quality of services can be applied to the classified traffic to provide the appropriate network resource among the defined classes. Therefore, classification is an important first step in configuring quality of services in network infrastructure. So what is important? Classification. So here we show the example. This is the command show IP NBAR protocol discovery. This is the command. After running this command, we can see the name of protocol and there are three tuples input, packet count and byte count. Similarly here in output packet count and byte count. So here you can see protocol is HTTP, input is this much byte. So this simple shows output of Cisco iOS NBAR show IP NBAR protocol discovery command. This command shows the statistic gathered by the NBAR protocol discovery features, which provides an easy way to discover application protocol that are transiting an interface. The protocol discovery feature discovers any protocol traffic supported by NBAR and can be used to monitor both input and output traffic. The command displays statistics for all interface on which the protocol discovery feature is currently enabled. So the default output of this command includes average 30-second bitrate in per second, input byte count, and input packet count and protocol names. So this is here secure HTTP, SNMP, Telnet, NTP, and DNS. So here you can see what are the things associated with NTP. This 0 indicates number of byte count. This 50 indicates number of byte count. Okay, and similarly here for output it is written like this. Output is 79364 and packet count is 640 42528 and byte count is 1655. Okay, this is another example or for tool for analyzing traffic net flow. Here the command is show IP cache flow. Okay, this is already discussed. So NetFlow switching provides network administration with access to detailed recording information from their data network. NetFlow is also provide a highly efficient mechanism with which to process security access lists without paying as much of a performance penalty as other available switching methods incur. So what are the things when we run show IP cache flow? It will display protocol, total flows in second, packet, byte, packet, active, idle. So what is the, let us see different fields like byte. Number of bytes of memory used by network flow cache. So this is byte. Okay. Active. Active is given here. So number of active flows in netflow cache at the time this command was executed. Then inactive. Inactive is, it is written number of flow buffers allocated in NetFlow cache. Okay. Added. Added is number of flows created since the start of summary period. Then agar poll, number of times the NetFlow code looked at the cache to expire entries. Flow alloc failures. So flow alloc here active and agar pole, exporting flow exported in this, everything is written. So in this statistics, number of times the net flow code tries to allocate flow but could not. Exporting flow, IP address and UDP port of workstation to which flow are exported. Flow exported, total number of flow exported and total number of UDP datagram sent. Fail, number of flows that router could not export. Last clearing statistics, standard time output, hour, minute in second, since the clear input flow statistic command was executed. Activity by each protocol display field description is protocol, total flow, flow per second, packet per flow, byte per packet, packet per second, activity, active second per flow, and idle second per flow. So protocol is, it may be TCP, IDP, UDP, whatever protocol associated with particular port number, number of flows. For this protocol, since the last time statistics were cleared, average number of flow seen for this protocol is flow per second. Packet per flow, average number of packet in the flow seen in the for this protocol. Bytes per packet, average number of bytes in the packet seen for this protocol. And packet per second, average number of packet for this protocol per second. And active second per flow, sum of all second from first packet to last packet of an expired flow. And ideal second per flow, sum of all the second from the last packet seen in expired flow. So here it is very difficult to remember all this thing, but some important thing, traffic is always associated with flow. Flow of what? Flow of byte, fine, packet. So these are the important things. So we need to check what are the things associated with byte. Similarly, if we say byte, then whether it is active or inactive. Okay. Similarly, if we are using traffic, then protocol has very important protocol has very important role. So there are different type of protocol. One is streaming and another is datagram. Okay. So we need to check what kind of flow we are using, whether it is UDP, it means datagram, and streaming means TCP protocol. So with this description, you can write your answer. See how to analyze net flow, how to analyze traffic using net flow. This is another tool for traffic analysis, Cacti. It can display daily traffic. So here you can see it shows inbound and outbound packets, unicast packet in and unicast packet out. So likewise, you can see data queries SNMP interface statistic. So on the basis of this, we get the traffic, and this is very important in cloud computing applications also. If you go to some cloud computing companies, there you can see they are monitoring constantly for the traffic. This is one more tool. solar winds, Orion. It, it can display the utilization of particular interface like GSA, COC, gateway, and so on. So with this, we can analyze the traffic for network. Now come to network health checklist. There are different things associated with network health, and it is very important to check all the criteria associated with network health. Some of the things associated with network health checklist is these are the check boxes you need to ensure whether the things satisfy or not. So first thing is no shared Ethernet segments are saturated, no more than 40% network utilization. Okay, so this is one. Second is no WAN links are saturated, no more than 70% network utilization. Third is the response time is generally less than 100 millisecond. 1 millisecond is 1 divided by 1000 second. So 100 millisecond is 1 divided by 10 of a second. Next is no segment have more than 20% broadcast or multicast. Next is no segment have more than one cyclic redundancy check error per million byte of data. Next, on Ethernet segment, less than 0.1% of the packets result in collision. Next is the Cisco routers are not overutilized. The 5-minute CPU utilization is no more than 75%. Next checklist is the number of output queue drops has not exceed 100 in an hour of any Cisco router. Similarly, the number of input queue drops has not exceeded 50 in an hour of any Cisco router. Next is the number of buffer misses has not exceeded 25 in an hour of any Cisco router. And last but not the least, the number of ignored packets has not exceeded 10 in an hour or any interface on a Cisco router. So these are the important checklists. On the basis of these checklists, this is sample checklist. You can modify the criteria according to your network, but this is very idealistic kind of checklist. On the basis of this, you can monitor your network health. Now, it is very essential to generate summary report. The result of network characterization process is summary report that describes the network's health. The customer input, network audit, and traffic analysis should provide enough information to identify possible problems in the existing network. The collected information must be collated into a concise summary report that identifies first thing is what first thing it identifies features required in the network. Second thing is possible drawbacks, possible drawbacks of and protocol in the existing network. Third thing is actions needed to support the new network's requirements and features. With this information, the designer should be able to propose hardware and software upgrades to support the customer requirement or to influence change in requirement. So here we can see the sample summary report. The network uses 895 routers, 655 routers use Cisco iOS software version 12.3 or later, and so on. So this report is generated. What is requirement? quality of services, congestion management, queuing required in the when identified problem. For this purpose, what we need to do, and what are the recommended actions, and what are the alternatives we can choose. So on the basis of this, we can generate the summary report. This summary report is very helpful. The summary report conclusion should identify the existing infrastructure's shortcoming. So in this particular figure, we can see that QoS congestion management or queuing is required. However, the designer has identified that Cisco iOS software version 12.0 does not support the newest queuing technology. In addition, some routers do not have enough RAM and flash memory for an upgrade. So, summary report recommendations relate the existing network and customers' requirement. These recommendations can be used to propose upgrading of hardware and software to support the required features or modifying the customer's requirement. Here, option includes evaluating the necessity of queuing requirement in the WAN. So let us create a draft design of this document. So this is the draft, okay? Customer input, network audit, and traffic analysis. The first diagram with arrow we have seen. So there are three phases: customer input, network audit, and traffic analysis. And immediate feedback from customer is also very important. So draft design document for Cisco. Immediate feedback is also there. Analysis and recommendation based on collected information and requirement of the design. Customer input is also there, and already existing information is also there. So in this thing, design requirement, existing network infrastructure, network topology, or network audit, application used in the network, network health analysis, recommended changes to existing network, and list of existing network devices and configuration of existing network devices. So suppose you want to do something in for your own organization, okay? So you are a owner of your organization, or you are engineer of your organization. You want to do, or you want to implement quality of services parameter. For this purpose, you need to propose particular thing, and you need to take the feedback from customer and network audit and traffic analysis also. Based on this, you can recommend that what will be our requirement, and which topology gives us better throughput, and how network is checked or audited, application used in that particular network. On the basis of this, we prepare the draft. This is very standard draft. On the basis of this draft, we can send the request for proposal for particular devices. So typically, draft documentation for an existing network should include: first item is logical layer 3 topology map or maps. Divide the topology into network modules if the network is too large to fit into one topology map. Next is physical layer 1 topology maps or map. The network audit result including the type of traffic in the network and traffic congestion point, the suboptimal traffic path, and so on. A summary section describing the major network services used in the existing network, such as open shortest path first, border gateway protocol, and internet protocol security IPsec. A summary description of application and overlay services used in the network. A summary description of issues that might affect the design of established design requirements, a list of existing network devices with the platform and software versions, configuration of existing network devices usually attached as either a separate document or appendix to the design document. So with this, we can create the draft for design document. Okay. So this is like a major project or minor project. First thing is the experience of network engineering. So this is very important factor. This section gives guideline to estimate how long it may take to characterize a network. The time required to characterize a network varies significantly depend on factors such as first important thing is the experience of network designer or network engineer. Second thing is the Quality of documentation, how better the documentation is done by the customer, and quality of communication with the customer. Quality of documentation as well as communication with the customer. Third thing is the size and complexity of network. Fourth thing is whether or not network devices are currently managed via SNMP. Fifth is how much information is needed for the scope of project, degree of information. So these are the things. So based on experience of a network engineer and the quality of documentation, size and complexity of network, and the manageability of SNMP devices and degree of information decides time. So this is the timeline. Okay. So this provides a range of time estimates in hours for the characterization of network in a variety of sites. These estimates assume highly skilled like Cisco certified internet expert level network engineer with efficient automated tools for network discovery and performance gathering and network in which devices communicate with SNMP. The network characterization include strategies, evaluation and possible network redesign. So here you can see first thing is interviewing the management team to gather tools. Okay, so interview of management team to gather goals and constraints, interviewing the network team and gathering goals, constraint, documentation and diagram already discussed. Then reviewing the documentation, set up network discovery tools already discussed, resolve SNMP access and similar problems, allow tools to gather data, analyze, capture data, prepare high level layer 3 diagrams, prepare report stating conclusions, incremental effort, the life cycle model to prepare network diagram, total estimates manpower in the hour. So these are the parameters. Main important thing resolving SNMP access and similar problem if devices have not been very carefully managed in the past. Next is allowing the discovery tool to gather data. The time for this step will vary depending on network and should include seasonal or cyclical factors, but generally 1 week of data is sufficient. The network engineer typically does not need to oversee this process. Okay, so the estimate do not include time needed to prepare detailed network diagram if customer does not supply them. Consequently, network characterization typically takes from 1 to many weeks of effort depending on size of complexity of network and other factors mentioned in the beginning of this project. So here for a small network 1 to 20 switches and router, this is a proposed timeline. And for medium network, for large and for very large network, so this is the total estimates in hours, 2 to 3 days, 4 to 6 days, a month, or maybe more than a month. Likewise, we can characterize the estimate. So generally, from this unit, the questions may ask like, how does traffic analysis help in characterization of network? Okay. List some site contact information that would important for project involving remote deployment when equipment delivery and installation must be coordinated. List some tools that can be used in network assessment process. What type of tool can be used during the network design process? So these are the question answers which already answered in this video. So this is our summary diagram. Okay, means whatever things we have discussed in this chapter, this particular topic, customer input. So what are the required input? Simple site contact information, simple high level network design, then auditing or assessing existing network, tools for assessing the network, manual information and automatic information. Cacti is very popular tool for that. Then analyzing network traffic and application. Tools for analyzing network traffic includes NBAR, NetFlow, other network analysis tools are also given. network health checklist. There are set of 10 to 12 questions, and then summary report generation, what is existing, what we need to modify, and what are the different parameters on the basis of which we have created summary report. And then creating a draft design documentation. This documentation is very important on the basis of expertise of engineer documentation and complexity of network and information related with this particular project estimates the performance of network characterization. So with this we finish this topic, and with this we finish characterizing the existing network. In next lecture we will see using the top down approach to network design. So thank you very much. Have a nice day.